Hello, my name is Arpita. So I'll be taking a small demo on process synchronization in operating system. Let us see what is process synchronization and what is the need for process synchronization here. In a process synchronization, there are multiple processes running in our system. They can be run in two modes, that is serial mode and parallel mode. So serial mode is nothing but the process is going to run one by one. So when one process is going to run, the previous process, the one process is running, the next process cannot come into the system until the previous process has been terminated. This type of process is called, this type of mode is called as a serial mode. So for example, we can tell ATM machine, where a person is doing his transaction in the ATM machine, until the particular person completes his transaction, the next person cannot come in and do his transactions. So in this particular type of serial mode or serial mode of transaction, we can tell in serial mode, we can tell there can be of no problem here. So when one process completes, the next process is going to come into the system. But in parallel mode of execution, what is going to happen is, nowadays we are going to have a system such as multi-programming system and time sharing system. Here we cannot guarantee that only one process is going to run in the entire system at a time. So simultaneously there might be multiple processes which is running in the particular system. So there can be some problems here, how these multiple processes are going to run at a time in a time sharing system. So here the process is going to be categorized into two types. One is in parallel mode. We are going to categorize the process into two types. One is cooperative process. One is independent process. Okay, let us see what is cooperative process. Here, the execution of one process is going to affect the other process. In cooperative process, when we are executing one process, affects the other process. Basically, in cooperative process, when we are executing one process, it's going to affect the other process. Why? How is going to execute? Here, there is the main point here is these processes have something in common. Common in sense, they might be sharing a variable. Maybe the code has been shared, memory, buffer. Also resources can be shared. So resources in sense printer, scanner or file. So here in this particular process, in cooperative process, there is something is common between the processes where it's going to share and it's going to affect. So this type of process we call as a cooperative process. So let us come to the independent process. Here the execution of one process is not going to, simple it is, executing of one process is not going to affect the other process. It's very independent. So if I have to give you an example like SBI server, there is two servers. One is SBI online server and HDFC online server. Both are running simultaneously at the same time, but since these are of different servers, it's not going to affect the particular process. So this is going to run in a different server. This HDFC online is going to run in a different server at the same time, but there is no effect. There is no any effect in this particular transaction. This type of process we call as a independent process. So here there is nothing much we can discuss here in independent process, since it's not going to affect the simultaneous processes, since it's very independent. But in cooperative process, we need to see how the process is getting synchronized and what is the need for process synchronization in cooperative process. So let us take a small example. for cooperative process, how we can get a process synchronization and what is the need for process synchronization in cooperative process. Let us see an example here. Since I said like in cooperative process and something is going to be common, maybe the processes are going to share some variables or resources or memories. So here I'll be taking a shared variable with an integer value and the variable name shared. It's been initialized to 5. And there are two processes, P1 and P2. Here in this two processes are going to run at the same time and it's in a parallel mode. These two processes are in the parallel mode. So let me write a small C code for P1 and P2. Partial code I am writing. So let us see the two process. This is a C code where it is going to share a particular variable, shared variable with the variable name shared, which has been initialized to 5. Since it's in the parallel mode, both the process are going to come into the system at the same time. But we are running a uniprocessor. So what happens is we are going to get CPU is going to take only one process at a time. So just imagine that we are taking the P1 process first, CPU is executing the P1 process first. So how it's going to execute? So shared is 5, so X is going to be 5. X has been incremented to 6. The third instruction is sleep 1. So we are telling the process P1 should be paused for 1 second. So what are we doing here? We are preempting this particular process P1. We are pushing it out from the CPU, and then CPU is never going to be idle. So we are pushing the particular process P1. So what happens when you are pushing? There is something called as a process control block. All the details of this particular process P1 is going to be saved in the process control block of P1. So next what happens, CPU is never going to be idle. So what happens, it sees that P2 is in the ready queue. It picks the particular process P2 and it starts executing the particular instruction 1. So here shared is going to be, Y is going to be 5. And next instruction is Y is going to be decremented to 4. And next when it encounters this particular third instruction, that is sleep 1. So here we are telling that P2 process is being paused. Basically it's been preempted from the particular CPU and paused for 1 second. What happens that time? The PCB of P2 is being saved, and since 1 second has been done by the P1, so what happens? CPU goes back to the particular process. CPU goes back to the particular process P1 and it starts executing the instruction 4. Because since PCB has been saved, all the details of particular process P1 is been there, and the next instruction, fourth instruction, is being executed. Here, shared is going to be updated to 6. So here, the value of shared is going to be updated to 6. So once this is done, this particular process has been terminated. Next, CPU is going to continue its execution and it's going to come to the fourth instruction. It's going to come to the process P2 and it's there. It is going to execute the particular fourth instruction here, and Y has been shared has been updated to 4. These details we got it by the PCB 2. The instruction has been updated in the PCB 2 and the 4th instruction has been run and the shared variable has been updated to 4. Okay, all these things we have seen. Is it correct? Is the variable, since P1 is being shared by P1 and P2 is sharing the particular variable shared, is the value what we got for shared, is it correct or is it wrong? It is wrong because the actual value we have to get is 5. What are we doing? We are incrementing in this particular, if there is if it is properly being synchronized, what should have happened? The value of shared has been incremented to 1 and then in the P2 it's been decremented to 1. So the answer should be 5. But we are getting the answer as 4. Since we ran the particular process P1 first and then we are running the particular process P2, we got the answer 4. But at the same time, if you run the particular process P2 first and then if you run the particular if you run the P1 process, the answer is going to be 6. So here what is happening is both the process are in a race condition. It's something called as a race condition. This particular thing, both the process are in a race to who is going to win, whether 4 is winning or 6 is winning. If you execute the C code, you are going to get either 4 or either 6. So this particular problem is called as a race condition. Here this called as race condition, and this is the reason why we need process synchronization. Okay, this process synchronization problem can be solved by making use of some semaphores, locking methods, Peterson solution problem, and all these are the this is the reason why we need process synchronization in a cooperative process. Thank you.